Hi everybody. Before you are watching this video, you should have filled out the front of your note sheet. I am now going to go through some of the answers. You might want to pause it to actually read through them. I'm quickly going to describe what I did. To fill in the table, I took the absolute value of all of the x values. So if they were negative, I made them positive, and if they were positive, they stayed positive. I then took those points, graphed them on the grid to the right, and made this nice V-shaped graph. Questions 2 through 4 talk about how you would move this graph to get the graph of a different function. So those should be pretty self-explanatory. They're very similar to what we did in class. If you have any questions about these, ask us in class the next time you see us. For question 5, I am now moving the graph from number 1, 2 to the right, and 3 down. Notice that this point is actually what used to be at the origin. I'm going to graph the original points. They were over here. We're going to call that point the vertex of the graph. It's kind of like where everything, if you were to fold the graph, it's where everything would match up. The axis of symmetry, if you remember what that is. So the vertex is actually at 2, -3. So if you can think back to point slope form of a line, this equation actually looks very similar to that, except that instead of parentheses, we have absolute value, and the point on the graph is at 2, -3. So that's going to be very useful when we actually go onto the back of the sheet and do some notes. Before we do that, though, I wanted to ask you an interesting question. Is the point 10, 7 on the graph that we have right here? Now, since we don't have our axes going out over here, we don't have them going out to 10, it might not be a good way of answering the question. So I have a different way of actually figuring out, is the point 10, 7 on the graph? So since x is 10 and y is 7, I'm going to do a little substitution and see what happens. So 7 is going to go in for the y. We want to know, is that equal to the absolute value? I'm going to plug 10 in for x and write the rest of the equation. If it is equal, then the point is on the graph. But if it is not equal, meaning that we don't have a true statement, then that point can't be on the graph. Basically, what we're doing is making this equation, right here, a point tester. We're testing to see if that point is on the graph. So let's try this. We would do 10 minus 2, that's 8. We want to take the absolute value of that, and then subtract 3. The absolute value of 8 is 8, and when we subtract 3, we get 5. Is 7 equal to 5? No, that is a false statement. So I'm going to write a sentence. The point 10, 7 is not on the graph y equals the absolute value of x minus 2 minus 3, because the x and y values do not make the equation true. They're not equal. It's not an equation. It's not equal. So we're going to do more with that during the year, but we thought it would be a nice place to introduce that here. Anyway, on to absolute value functions. So what is the general form of an absolute value function? You've been using it all along. I'm going to write it as y equals a times the absolute value of x minus h, close up the absolute value, plus k. So, because something has the absolute value, means you're going to get the V shape. Don't forget that this thing right here, that is going to move something to the right or to the left. H spaces. The K is moving something up, down, K spaces. But since we're always moving the origin, that means that H comma K is our vertex. Whoops. Notice that in the general form that we have a minus sign here. So when there's a minus sign, the H is our vertex because it's been moved right. If you saw x plus a number here, then the vertex would have the negative value of that H. The A is the new part. The A is actually going to talk about the rate of change. You might know that as slope. Let me go right into an example so we understand what's going on. That was kind of weird. So, example 1, this A value is 2. The H value is a positive one. Remember, because in the general form, it has a minus sign there. So our vertex is at 1, comma, what's out here? Nothing. Well, what could you put there and not really have it show up? Plus 0. So our vertex is at 1, 0. Now, that might have seemed complicated. Let me give you the easy explanation. Look at this graph. How did it get, look at this equation. How did it get moved? Right 1. Well, we start at the origin, we move right 1. There it is. There's the vertex. Like I said, the vertex is at 1, 0. We now have to draw the V. You don't just draw a random V. This is where the A value comes in. If this value is positive, okay, let me go back up here and write this down. If A is a positive value, we have a V like this, and if A is negative, we have an upside down V like this. So on example 1, we have a positive 2. That means that we have a graph like this, and the positive slope side is going to have a slope of 2. So here we go, from the vertex, up 2 over 1, up 2 over 1. I'm only drawing this side in, because this point at 1, 0 is the vertex. To make a V, we have to have a negative side, or a negative slope. So I'm going to have the other side make a slope of negative 2. So I'm going to go up 2, left 1, up 2, left 1, and there's the other side of my V. Okay, for the second example, this time we have the graph, we want to write the equation. Okay, so it's called h of x. Let's start it with an h of x equals. How has this graph been moved? Well, if it started at the origin, it moved 1, 2, 3, 4 left, and 1 down. Or in other words, the vertex is at negative 4, negative 1. That's going to fill in h and k for us. So I'm going to put x plus 4 inside the absolute value, that moved it left 4, and a minus 1 on the outside to move it down 1. The a value is going to be positive. This is a positive v. Its slope, let's see, let's check this out. To go from here to here, I'd go up 1 over 1. Perfect. So its a value is 1, or you could just leave it blank, since it would be a 1 by default. Let's do some more. Okay. Make a graph of g of x. Ooh, we have a negative a value. Don't forget that means this is going to be an upside down v. It's only been moved up 4. Excellent. So I'm going to say that the graph started at the origin, moved up 4, like that. That's our vertex. A slope of negative 1/3 means I go down 1 over 3. Down 1 over 3. There's the right side of our v. Go back to that vertex. Now let's go down 1, left 3, down 1, left 3 to get the other side. Notice that slope would actually be positive. And that's it. We're done. Nice and simple. We're going to leave number 4 to you to try. Notice the V is upside down. What type of A value are you supposed to have? Think about it. We'll talk to you in class.